All right, here's a quick bonding review video before I take off. Bond. We talked about the three phases of bonding. 1, 2, and 3. And that's what I'm going to touch on today. Hopefully this helps make sense of all that stuff. Best way you can review for this test is definitely going through those questions, being able to answer the questions, understanding going from the properties to the types of bonds, and understanding what they all mean. Okay? Phase 1 of bonding is the bond between the two atoms. What holds two atoms together, regardless of what else is around them. Okay? There's two types that we've really talked about. We've talked about ionic and we've talked about covalent. I can absolutely say that metallic is up here too, even though we didn't talk about it until phase 3. Okay? One thing you need to know about metallic bonds, sea of mobile electrons. They're the only solid phase conductor. Okay? Ionic bonds have an electronegativity difference of greater than 1.7, usually a metal and a non-metal. Okay? Electrons are not shared, they are transferred or stolen. Form ions here, you've got positive and negative ions. Okay, so in an ionic bond, you have a full plus, and a full minus. Okay, they stick together in a crystal structure. Covalent bonds, a non-polar covalent bond, again, is determined. Bond polarity is determined by electronegativity difference. Non-polar, END equals 0. Okay? If you have a polar covalent bond, your END is between 0 and 1.7 is your magic number. Okay? That's how you tell if a bond is polar. Polar just means are they sharing nicely or not. If it's a really polar bond, one atom gets the electron more than the other atom. If it's a non-polar bond, they share the electron equally. Okay? Electrons here are shared. It's usually two nonmetals. Okay? Additionally, when you have a covalent bond, if it's nonpolar, there's no charge. We show shared covalent electrons. Two electrons form a bond. We show shared ones like that, like a line, okay? If one is stronger than the other, that means it's more electronegative. It's got a partial negative. We've got a partial negative and a partial positive across that bond. That's a separation of charge across a bond, okay? Metallic, here we have a sea of mobile electrons. That's phase 1. Moving on to phase 2. What shapes do these things take? Let's use a different color, shall we? What shapes do they take, and how does that affect their properties, which is later in phase 3? Ionic bonds form a crystal lattice. Okay, it's a network of ions. That's all you need to know. Okay? Covalent bonds form shapes. They form molecules. Notice we have not yet talked about polarity with ionic bonds. Ionic bonds have nothing to do with polarity, okay? Covalent bonds can be polar or nonpolar. We tell that by electronegativity difference, okay? Molecules, polarity depends on their shape and their symmetry, okay? Bent and pyramidal are always polar. Polar molecule, that means asymmetrical. Asymmetrical polar. Okay? If it's tetrahedral, linear, or trigonal planar, it's usually nonpolar unless your central atom is bonded to multiple different elements. So I'll say to different elements. Okay? So here's an example. Let's do my favorite methane, CH4. Remember when you're drawing these shapes, do the dots, okay? I've been drawing them forever, and in the nature of time, I'm going to go quickly. But count valence electrons, make sure everyone has 8 or 2 in the case of hydrogen, and make everyone happy. If you do not do that, you will not get the right shape. This bond here is polar between hydrogen and chlorine. It is polar. Hydrogen has a lower electronegativity than carbon, okay? However, this whole molecule, let me redraw that. Whole molecule is nonpolar because it is symmetrical, okay? It is symmetrical, nonpolar. However, as soon as I change this hydrogen to a fluorine, my carbon is no longer bonded to the same thing. It's bonded to hydrogen, 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 and fluorine. This becomes asymmetrical polar. I have a pole here, okay? I have a negative end and a positive end. You don't need to know a ton about shape names, but you do need to be able to tell about the polarity. So knowing shapes does help, okay? Remember that when you draw things like O2, you need to know has a double bond. N2, you need to know has a triple bond. And CO2, you need to know is linear and nonpolar because it is a carbon with a double bond on both sides to oxygen, okay? Things get bent when they have lone pairs. This carbon has no lone pairs around it, okay? Make sure you draw those lone pairs in. Metallic shapes is a metallic structure, okay? It's a malleable crystal structure. There's no additional information there. All right, finally, I'm going to erase this so I have some more room. Phase 3. Phase 3 is the forces between molecules, and I'm going to write that rather than draw it. The forces between the molecules. Ionic, they're ionic forces. Okay? Metallic, I'll put it way over here. They're metallic forces. How do you know it's a metal? It's a metal. Look at your periodic table, okay? How do you know it's ionic? You can start at phase 1 and work your way through. Network solids that you need to know. They are covalent bonding, but there are specific ones. Carbon, graphite or diamond, silicon carbide, and silicon dioxide are all network solids. That means they have high melting points, high boiling points, are not soluble, do not conduct, okay? Ionic bonds have high boiling points and melting points, okay? The big thing you need to know about ionic bonds is they conduct when aqueous or liquid, okay? Net solids are non-conductors. Ionic bonds conduct when they're aqueous or in a liquid form. Okay, if you have a covalent molecule, what holds those molecules together? That's really important. The molecules are held together, not by covalent bonds, okay? Covalent solids have low melting points and boiling points. They're generally soft. They're generally non-conductors. Okay? And they sometimes are soluble in water, but not always. There are 3 types of forces. Hydrogen bonding, dipole-dipole. I'm going to put dipole squared in the interest of time. Oh, where did my little thing go? Okay, well, we'll see. And dispersion. Okay? Dispersion is if your molecule shape up here is nonpolar. It's dispersion. Nonpolar. That's symmetrical nonpolar. Okay? Dipole-dipole is polar for polar molecules. Hydrogen bonding is a special case of a polar molecule with hydrogen bonded to fluorine, oxygen, or nitrogen, okay? That's your special case for hydrogen bonding. Highest melting points are network solids, then ionic, then metallic, then hydrogen bonding, dipole, dipole, then dispersion at the bottom, okay? So if you have you have to compare them, that's how you compare them. What else was I going to say? Metallic conducts electricity as a solid, liquid, whatever. It also conducts, it is also not soluble in water, reactive with acid, generally pretty strong and hard, and has a high melting and boiling point. Okay? Hopefully this helps. Additionally, if you're watching this and you want the key to the Q bonding of an atom worksheet that I gave you for review, I will read in order. The key is 4, 1, 2, 4, 1, 1, 3, 3, 1, 4, 1, 2, 4, 1, 4, 4, 4, 4, 4. So 15 through number 19 are all 4. Okay? Hydrogen bromide is a polar molecule, and carbon tetrachloride is a nonpolar molecule. Email me if you have any questions.